Bismillahirrahmanirrahim. Welcome to topic 8.6, deadlock avoidance. For this solution, it requires that the system has some additional information that is available. The simplest and the most useful model requires that each thread declare the maximum number of resources of each type that it may need. For the deadlock avoidance algorithm, it will dynamically examine the resource allocation state to ensure that there can never be a secular wait condition. So what is the resource allocation state? The resource allocation state is defined by the number of available resources, the number of allocated resources, and the maximum demands of the threads. So this is what we call as the additional information that is required. So we have two types of deadlock avoidance algorithm. The first one is resource allocation graph. The second one is Banker's algorithm. So we will, inshallah, we will cover both of the topics on the next videos. So now we continue with the topic 8. Before I forgot. We will look at the example of the resource allocation state. At the end of the subtopic 8 point. At the end of the subtopic, safe state. Now we look at the safe states. What is safe state? When a thread requests an available resource, first system must decide if immediate allocation leave the system in a safe state or otherwise, meaning that is it in a safe state or in unsafe state. So what is a safe state? Safe state is there exists a sequence of T1, T2 until Tn of all the threads in the system, such that for each T1, the resources that T1 can still request can be satisfied by currently available resources, and the resources held by all the Pj with J must be less than I. We will look at the example for you to more understand about it. So that is if Pi resource needs are not immediately available, then Pi can wait until all Pj have finished. When Pj is finished, Pi can obtain needed resources, execute and return allocated resources, and finally terminate. So when Pi terminates, Pi plus 1 can obtain its needed resources and so on. So we can see that, sorry, not P. I should say I should mention T instead. If we look at this, seems like this is regards on Pi. This is for the Pi plus 1, while this is a Pj, or actually we can say Pi minus 1. We look at the example of a safe state. Let's say we have a system with 12 resources and 3 threads. We have T0, T1 and T2. This is what we define as additional information. Remember, we need 3 types of additional information: the maximum resources, the current needs, the maximum needs of resources, the resources that has been allocated for each thread, and also what is the currently available resources, or also known as free resources. So in this scenario, we have 3 currently available resources. So at the time T0, the state is in a safe state. Why? Okay, because at the time t0, since we have 3 free resources, so we can immediately allocate all the resources needed by t1. Okay. Right, so remaining, so when we allocated all the resources needed by T1, okay, so the remaining free resources is 1. Yeah. So after T1 after T1 terminates all of its execution, it will return all the resources. Okay, so the currently available resources is 1 plus 4. So the free resources now is 5. Okay, so 5. So we can now we can fulfill, or we can we can fulfill, or we can grant all the maximum needs of thread T0. Okay, so since we have 5 available resources. Okay, so after T0 terminates its execution, it will return all the resources that that has been allocated to them. So now we have 10 currently available resources. So since we have 10, okay, we can allocate the resources to T2, since it still needs 7 resources. Okay, so since we have 10, so we can grant all the resources that needed by T2. Okay, that's why the sequence satisfies the safety condition. We start with T1, followed by T0, and finally T2. Okay, so this is what the scenario is in a safe state. So now we look at the for the unsafe state. Okay, the example of unsafe state. Right, guys, this is already the record the duration is already achieved 7 minutes. So I will continue on the next video. All right, thank you for watching.